So we're now done with the sort of very basics of the shell, and we're now going to go beyond thinking of the shell as like a file navigator and really look at some of the functionality and the power of the shell environment to work very easily on large numbers of files and to perform custom analyses by combining different individual commands together. So to proceed, we are going to work in the molecules directory again. If the current working directory of your shell is not the molecules directory, then you will need to do some cding in order to get to the right place. Otherwise, let's just remind ourselves that in this directory we have these 6 files that are in this PDB format that describes, well, these files are used to contain descriptions of molecules, essentially. So let's try and ask ourselves a sort of research type question of this set of files, and we could ask ourselves, of the molecules described by the PDB files in the current directory, which of these is the smallest? If we happen to know a little something about the PDB format, then we know that each atom in a molecule has its own line. So we can convert this question into which of the files in the current directory has the fewest lines. So we're going to look at writing an analysis in the shell now that will tell us which of these files has the fewest lines. And to do that, we're going to need several different commands, and we're going to combine them all together to do one thing. The first of these commands is going to be WC. WC is just short for word count, and if you provide an argument with WC, here we'll provide Cave-Ayland.pdb. Then we get a little output. It's not terribly well explained, but I can break this down for you. Word count gives you 3 pieces of information about the file. So the first bit of information is the number of lines. So Cave-Ayland.pdb contains 20 lines, 156 words, and then 1,158 characters. Word count can actually accept more than one argument, and we can combine this with the wildcards we just saw in the last episode to get the information for all of the files in the current directory very easily. So we can run wc *.pdb. As discussed previously, the *.pdb will be expanded and it will match every file in the current directory. And the output we get from word count supports this. We get information on all 6 of the files, the number of lines in each, and so on. We also, when there's more than one file provided to word count, it also provides this total line at the bottom. So at this point, maybe our task looks slightly trivial, right? We can easily look through the output of WC *.pdb and see which file has the fewest number of lines. It's methane, has only 9. So this works okay where we have a small number of files, where we only have 6 files. If we were to have, say, 6,000 files, then our whole screen would be filled up with all of this information, and we'd have to do a lot of scrolling back to find and remembering and double checking, etc., to make sure that we definitely found the entry with the fewest number of lines. So what we're going to do is we're going to write a shell command that's going to automatically pick out this line for us without any further need to think or look or interpret on our part. So the output of WC at the moment is giving us some extra information about the words and characters. We're not particularly interested in that, so we can simplify the output using a flag to WC, which is -l *.pdb. If we execute that, then we only get the line information. So -l just asks WC to only provide line information. So we have, using WC, we can get all the information about the number of lines in each file, but we now want to work further with the output of this command. At the moment, it's just being printed into screen. So we could sort of, try and we could highlight all this, and then we could copy paste it into a text editor, save it as a file. But that's all very cumbersome and not very easy to repeat. Fortunately, the shell provides us with a very straightforward mechanism to save the output of a command into a file. So if we want to, we can repeat the last command, wc-l start.pdb. You can actually use a little cheat here. You can use the upward arrow on the keyboard to scroll through your history of commands. If you press it up the arrow once, then you will retrieve the last command that was run. We're just going to add to the end of that greater than length.txt. If we execute this command, suddenly we don't get any output from wc anymore, but if we run ls in the current directory, we can see that we have a new file, length.txt. As you may guess, the the output of the wc command has been stored as the contents of length.txt, so that we can now work with it further very easily. We can just double check the contents of that file using a handy command called cat. This is the sort of first kind of unintuitively named command we've seen today. Cat is short for concatenate, and it can be used to join multiple files together, but here we are just going to use it to print the contents of a file to the screen. We provide cat length.txt, hit return, and indeed we see that the content of length.txt is exactly as it was when we ran the wc command. So we can now use the output of wc with a new command in order to sort these output lines according to the number of lines in the file. The command for this is, as you may guess, sort. We need to provide sort the -n argument. The reason for this is to tell sort to interpret this first column as a number rather than as a set of characters, and make sure that it sorts it by the value of the number that is described. Don't worry if you're not entirely clear on that. There's an exercise you'll have a chance to look at later which looks at this in more detail. So we need to provide sort -n, and then we can tell sort to work on to sort the contents of length.txt. Return to execute, and you can see that we've got the result we wanted. The contents of the file, contents of length.txt, has been sorted according to the number of lines in each of the files, with methane.pdb at the start. It's important to note here that sort does not change the file. Sort is just outputting to the screen. Length.txt, if we do another cat length.txt, we can see the file itself is unchanged. So let's use the up arrow twice to go back to sort-n length.txt. And as before, let's store the output of this in a file using greater than sorted length.txt. So this highlights an important thing about the greater than symbol, which is that this is a feature of the shell. It's not a feature of the wc command. So this syntax can be used with any shell command, and it will store the contents. It will store any output that would have gone to the screen, normally into a file instead. This process is known as redirection in the shell. So we say that we have redirected the output of sort to sorted lengths.txt. Execute that, and as expected, we don't get any output to the terminal because we have sorted it. So we now have we can see the contents of sorted length.txt, and we now just want to grab the single top line from the file, because that is the only one that contains any information that we're interested in. We just want to know which the shortest file is. To do this, you can use the last command we're going to look at for this section, which is head. The role of head is simply to look at the top of a file. If we provide the -n1 option here, then we are telling head that we only want to look at the first line of the file, not any others. And if we then provided sorted lengths.txt, then indeed we get the output that we want. Just methane.pdb and indeed the number of lines in that file. So this is one way in which you can use multiple commands together, and in a minute we will have a look at how you can do this even more quickly and conveniently.